Hey guys, what's going on? It's me, Mr. V. You know, I really love driving. There's nothing I enjoy more than the feeling of power and control that I have when I'm behind the wheel. However, driving is a big responsibility, and it does require that you look at a lot of measurements. Measurements are a huge part of our life, and there's nothing better than looking at the car as an example of the many measurements that need to be taken. So hop in, take a look. So this unit is all about making measurements, which of course in chemistry you will be doing a lot of. Now, in chemistry we study matter and the properties and changes of matter. So whenever we observe matter, there are a lot of observations that can be made. The first type of observation is called qualitative. And in a qualitative observation, we will be describing things like color, odor, shape, or other physical characteristics. If you look at the root of qualitative, you see the word quality. And that's because qualitative observations simply describe the quality of the matter we're observing. Another type of observation that we can make when describing matter and making measurements is quantitative observations. And quantitative, as you can see, is going to give us numerical information describing how much, how little, how big, how tall, or how fast something is. And you can see the difference in the root. Here we have the term quantity. The term quantity refers to a number. So whenever making quantitative observations or quantitative measurements, you will always have a number involved. So let's describe the term measurement. After all, that's what this entire unit is going to be about. So what exactly is a measurement? Well, it's a collection of quantitative data, meaning data that includes numbers. Now what we're going to see is whenever we make measurements, what we're actually doing is we're comparing the quantity of interest with a standard, which we call a unit. And what you're going to notice is this comparison is never perfect. As a result of this imperfection, measurements will always include error. Alright, so here we're going to be looking at a couple of examples of some different observations we can make, along with some different measurements that can be made. Now, as you know, a beaker is never used to measure, However, it is a good tool for giving you approximates or estimates, kind of like our old system worked. Now, in this beaker, we have a blue liquid. To say that the liquid is blue is a qualitative observation because it simply discusses the quality of the substance. However, if I were to say I have approximately 75 milliliters of blue liquid in here, then the 75 milliliters, which includes a number, is now a quantitative observation. So another quantitative observation might be commenting on the beaker itself. I can measure the height of the beaker at about 8.9 centimeters. Or I could discuss the quality of the beaker by discussing that it's glass or shiny or clear. You can see again a difference of a quantitative versus a qualitative observation. Other quantitative observations might include the width or diameter of this beaker at about 7.1 centimeters. And I could also transfer this liquid over to a graduated cylinder and get new types of observations. Now, as you will know, a graduated cylinder is your preferred tool for making measurements of volume. While the beaker can give you approximate values of volume, it is really only best to contain or to pour solutions or liquids. Now, in here it appeared that we had about 75 milliliters of the blue liquid, and upon closer inspection here, I really only have about 69 milliliters. So you can see the inaccuracy involved here and the preference to the graduated cylinder for this reason. So the 69 milliliters of liquid in here is another example of a quantitative observation that has been made. Again, I can measure the height and I can see that it's about a height of 25 centimeters. Now, one thing I want you to notice is, as I mentioned before, all measurements are really just, in a way, going to have some degree of estimation. There's always going to be some degree of error involved. Of course, I could use more precise instruments, as you saw, and get a little better or closer to the result. However, in the long term, measurements in themselves are just innately going to have some degree of error, so keep that in mind. Alright, so I got a problem for you. I'd like you to solve the following. Well, a lot of you are looking at this and probably guessing what this result may be. But in reality, you have no idea what this answer is because you have no idea what operation to perform. And the main reason for that is these numbers are meaningless. In chemistry, numbers alone are never enough to solve a problem. You need to assign value or meaning to these numbers. So let's talk about the difference of a number versus a quantity. A number without a unit is simply naked and gives us no meaning at all. However, what we've seen already is that whenever we make measurements, what we actually obtain is a quantity. So what is the big difference between a number and a quantity? Well, a quantity consists not only of the number, but also of a unit or a label. And what you're going to notice is this label or unit gives this number more meaning. So now let me present the following to you. A classroom can hold 30 students per room. Our school has 3,000 students. How many rooms would be necessary? Well, you can see the exact same numbers are presented to you. However, now these numbers have a label telling you exactly what these numbers mean, giving you a visual to understand this problem. And as we can calculate, we would need 100 classrooms to accommodate these 3,000 students. So now we are able to get an answer from this. So let's now talk about systems of measurement. Now, one system that we're all familiar with, especially here in the United States, is the English system. But in reality, it is only 3 nations in the world that use this system. That is us, the United States, Liberia, and Myanmar. So as you can see, this system is not really widely used or accepted. So this English system will include units of measurement that we're familiar with, like the cup or the ounce, or the quart or pint, or the gallon, the inch, the foot, the yard, the mile. It will also include the teaspoon, the tablespoon. You can see these are units that we're all familiar with, but the rest of the world uses a completely different system. So even though the English system is not without its faults, it still far exceeds the old systems we had in the past. The reason was old systems had measurements that were not exact. In fact, these were often estimates or just approximations. The old system included units of measurement like the foot, and I literally mean their feet. They would walk or pace and use that as a way to measure things. As you can imagine, this really led to inaccurate results and discrepancies because we all have different foot size and we all take different steps. Other things they used were the hourglass and the sundial, which again really couldn't give you exact measurements but did serve for great approximations. So, was a new system needed? As science progressed, we really needed to report data that can be reproduced by other scientists and experiments that could be replicated around the world. So it was clear that a new system was going to be needed, and this led to the creation of a standardized system. Thus, the international system was born. Scientists in 1960 from all over the world gathered and agreed on a single system of measurement. As you can tell, this is a French term called Le Système International des Units, or abbreviated SI. So as a result of this gathering of the great scientific minds of the time, it was agreed that the following SI-based units would be used. You can see we have things like the meter for length, the kilogram for mass, the second for time, and other things like the ampere, Kelvin, candela, and mole, which you will learn about in the future. But now we have one universal system that the entire world has agreed on, and we could all compare our results to one standard unit. So in this class, you will definitely need to get used to these units and this international system. So I definitely want to caution you because there's going to be a lot of desire to use words like inch, foot, yard, mile, pint, acre. However, these four-letter words are not allowed and are strictly forbidden in this class. And I know there will be some resistance, but you will learn to appreciate the beauty that comes with this international system. So hopefully you've learned a lot about measurement and the international system. Keep in mind, we are going to be taking measurements all year long, and the unit you must use will be one from the international system or some variation of it. Well, thanks for watching. We'll see you next time.